Welcome back to Pure Science Education. Today we'll be looking at the periodic table. As you can see, there is a periodic table in front of you. So what we're going to do is annotate the different parts of the periodic table. So if you go down this way, these are called groups. And then if you go across, it's called periods. Let's start by naming all the different groups. So this here highlighted is group 1, which is called alkaline metals. Here annotated or highlighted group 2 called alkali earth metals. Then we have this big chunk in the middle, I'm just highlighting now, and that is called transition metals. Then the other one over here, just highlighted group 7, called the halogens. And finally, this one here is group 8 or 0, called inert or noble gases. So this is a quick annotation of the periodic table. So if you was to then move on to look at how we can use this in our GCSE and A Level exams, we are going to look at what ions and so on it creates. So if I move this up for now, so after annotating your periodic table, you have got something like this, and like we said, we already named the groups. So 1, 2, 3, 4, 5, 6, 7 and 8. So the next thing that's important about after we have named the groups is, if you look at group 1, it has a +1 charge. Group 2 has +2 charge, +2 or +3 charge because it sits between group 2 and 3, +3, +4, -3, -2, -1 and 0. So what does these mean? These are your ions or those groups. So for example, if we look at group 1, group 1 has all elements that have 1 electron in the outer shell. So in group 1, all elements have 1 electron in the outer shell. So to get a stable configuration, it needs to lose this 1 electron, so it gets a +1 charge, because metals lose electrons. So if you lose electron, you get a positive charge, and if you gain an electron, you get a negative charge. So in the same way, if you are in group 2, you get +2 charge because you are losing 2 electrons. Now here, the transition metals could be +2 or +3, and in the A Level or GCSE exam, they will write down using Roman numbers 2 or 3. So then you know which one it is. Again, if you carry on, you got your group 3 there. So you got +3 charge on there. and plus 4. And then if you look here, we start to get minuses. Now the reason why we got minuses is to do with the energy level. So here I've got these ones here are your non-metals. So the difference between a metal and non-metal is non-metals gain electrons. If you gain electron, you get a negative charge. So for them to get a full outer shell configuration, they will be gaining those electrons. So if you add 5 plus 3 gives you an 8, 6 plus 2 gives you an 8, 7 plus 1 gives you an 8. The whole idea about anything from group 1 to 7 are reacting is to get full shell outer configuration like group 8, which has a 0 because it does not lose or gain electrons. It's got full shell outer shell already. So this is a bit about how the ions work, which ones are gaining, which ones are losing, and why they have those charges. The next thing we're going to look at is how which group goes with which and how does that work. So if I was to look at group 1 and group 7, they go in together. So group 1 is plus 1 charge because the element in group 1 will lose 1 electron in the outer shell. In group 7 they'll have a minus 1 charge because they will gain 1 electron, and the overall net charge will be 0 because they cancel out. We then look at ions in group 2 and group 6. Again, you have plus 2 and a minus 2, and then the overall charge is a 0. Then we go on to group 3 and group 5. You got a plus 3 and a minus 3 with a charge of 0 overall. So if we was to look at these in examples, so group 1, you have got sodium that has got 11 electrons, which is to a 1 configuration, highlighting the 1. If I then go to group 7, chlorine, that's got 17 electrons, it's got 287. So in order to get full shell outer configuration, sodium needs to lose that and chlorine needs to gain 1. So sodium will become a 28 with a Na plus charge. Chlorine will become a 288 with a Cl minus charge. And when you write the formula down, it becomes NaCl because you're cancelling the charges out. So this is quite straightforward if you have that ratio of where you're losing and gaining the same number of electrons. Let's look at an example where it does not work like that. So if I had group 1 element, so let's say potassium for example, that has 19 electrons, and then I have a group 6 element, say oxygen for example. So in order for so oxygen has got 8 electrons, 2 and a 6. So in order for them to balance out, so that will be 2, 8 and a 9, and that will be a 2 and a 6. So if you can see, I've now got 8 2 8 8. Oh, let's just take that one off. So I've got 2 and an 8, that gives you 10, and then you got another 8 and a 1, so that's 18 plus 1. And if you look at this one, I need to gain 1. So if I was to look at the 1 here and highlight that one there, and if I was to highlight this one here, what that shows you is that you need to lose that one and you need to gain 2 here. Now, because potassium only has 1 and 2A, 1 electron to lose, and oxygen needs 2 electrons to gain, which then means the ratio will be 2 to 1. That means I'm going to need 2 potassium to 1 oxygen. So let's write that out again. So the formula becomes K2O. So it's really important, one, that we write them out correctly and then find out how many do you need in order to write your formulas out. The other thing we can use for periodic table that you need to know is if you go down the group, the atomic radii is getting bigger. Because you have got more electrons as you go down, which means you got more shielding effect. Shielding effect is basically how far is your outer shell from the nucleus. And if you are looking at A level, then you need to know something about electronegativity, which means the ability for an element to take off electrons and pull them off. And if you go down a group, the electronegativity decreases. But if you go across, so you're moving from left to right in a periodic table, the electronegativity increases. So this is a quick whiz through your periodic table, labeling all your different groups, telling you all about what's happening as you go up and down the group, working out your formulas if you don't have them in the right ratios. Here the ratios were equal, so you had 1 to 1. So for today, this will be it. If you like the video, please subscribe and press like. Thank you.